So I'd like to introduce you to three of my colleagues at Google who've been working in these three areas, and they, along with others, have been instrumental in changing all that so that science fiction is now here. So first off, Geoff Hinton. Geoff Hinton is one of the pioneers of artificial neural networks. Artificial neural networks, and that will be the last of the methods that we'll get a flavor sense for on our menu, they are essentially many layers of mathematical transformations. Not much to do with brains. But if you have all these layers of transformations, you effectively have a very flexible recipe. And if you have such a flexible recipe, you are able to fit those boundaries for a much wider, more interesting class of tasks. I mean, think of those surface boundaries with neural networks. You can pretty much sign your name in cursive, which you can't do with a bunch of lines. So you can solve more interesting tasks because these algorithms are very flexible. The price, though, is you do need more data and more computing power to make them tick. So introducing Fei-Fei Li. Now, Fei-Fei started her career as a computer vision researcher at Stanford. And, well, actually, when this was going on, Fei-Fei was at Caltech. And Fei-Fei was thinking about why a 3-year-old human child is just so much better at this cat-no-cat game than any computer vision system out there. And she realized that 3-year-olds have something that computers don't have. A loving parent who bothers to give them a bunch of nicely labeled examples to learn from. The parent is saying, "No, sweetie, this one is a cat, not a dog." And she did a quick back-of-the-envelope calculation and realized that a human child would have on the order of millions or tens of millions of examples. She thought, okay, well, maybe that's why machines aren't succeeding. Of course, these computer vision folk who are trying to use a few thousand examples aren't going to get anywhere. You're not going to get performance like a 3-year-old. Based on that, fine. All I need to do is I just need to pick up a data set that's nicely labeled and big enough, and then off we go. All right, who's got this data set for me? It turns out people like their kids more than their computers and haven't bothered to make that data set. And so you can't have any progress. And Fei-Fei decided that she was going to change that. And whether or not they would force her out of grad school, she would sit there and organize a project around getting great examples, nicely labeled data that everyone could learn from. At some point in this project, she was running something like 60,000 mechanical Turk workers, all sitting there labeling things as cat, not cat, for you so you don't have to do it. And then when ImageNet, her project, launched in 2009, it had something like 2 million beautifully labeled photographs. And she made that available to everyone so that the whole community could make progress. But algorithms and data aren't enough. You actually need to be able to, lift and process that stuff. So you need the hardware and computing power. And Jeff Dean at Google is instrumental in the TensorFlow project. Now, TensorFlow, from the data scientist's perspective, looks kind of like most other data science frameworks, except much more finicky and annoying to program in. You force your data into the thing with some fuss, hit run, out comes a recipe, off we go. And you could probably do that in any programming language subject to your degree of masochism. That's not the part that makes TensorFlow magical. The part that makes TensorFlow magical is the way it uses the hardware. It doesn't waste it. What would have not been enough hardware, would have taken much, much longer, is now fast enough that this whole thing is viable. And then there's also this little bit about specialized hardware. And somewhere around 2010, some researchers noticed that the calculations that you need to do for neural networks are very conveniently performed on hardware that was developed for an entirely different industry, which is teenagers playing video games. And that's why you hear GPUs this, GPUs that all over this neural network space. Graphics processor units just happen to be pretty efficient for this, and so those researchers realized, Geoff Hinton was one of them, hey, if I just grab a standard gaming console and hack that thing, I've got myself a supercomputer for $300. And that's a big part of the birth of this AI revolution. So you've got the hardware, you've got the specialized processing frameworks, now open sourced, so everyone can use it and contribute to it. You've got the huge, beautifully labeled data sets and the algorithms.